All right, so this is part two of Aggregate series of lectures. And last time we talked about the chemical makeup and a lot of the aggregate properties, a little bit about gradation and a few other things. And so the first few pages that we're going to go over today is about kind of trying to bring together some of the properties and to truly understand more about specifications of aggregates. Unfortunately, this is just a few lecture series on specifications and how to apply how aggregates get applied in the field all the time. So I will not be talking long lecture about how they apply just to concrete or asphalt or to aggregate bases, or how to use them in subsurface drainage applications. Wish I could, but I actually have a long extended period of lecture notes that you can look at on optimizegraded.com, and it actually has all that stuff. So today we'll talk about specifications for a few pages, and then we'll actually talk about extracting aggregates, and also quarry production. Just kind of get some brief overall understanding of whenever you're talking to an aggregate producer and some of the stuff that they're telling you on the phone or whatever. Some of this is kind of just gives you the basic overview of what they're talking about when they're talking about their quarry production. And so to wrap up from last lecture, the majority of the time we care about specifications. So specifications are a detailed description of the quality requirements for an application. And so this can be in a contract, it can be in blueprints, it can be just blueprints that reference a published standard, or something that's just specifically written down in in the contract or in the blueprints. And these standard published standards can be anything from like an ASTM to AASHTO, Army Corps of Engineers, state DOTs. It's very common. State DOTs each have their own specifications. Then you also have different building codes that have published specifications. And so this is very important specifications for an owner, a contractor, a materials supplier, materials producer, inspector, so they can define and communicate in a legal, written, and sometimes it's just an oral agreement on what the requirements of the final product actually are. And so they can be done in many different ways. I am not going to go into great detail about contracts and specifications, but typically you have 4 different specifications types. You have methods or recipes, which is kind of a step-by-step process that people say that you have to complete work in general. And so contractors typically dislike this. They don't want to be told what to do. They just want to, they want to know a performance specification where, states whether acceptable work was actually done, or an end result specification where the work is completed and then random samples are taken and determined if it meets the specification. So this is typically what's done for aggregates in general, is either an end result or a performance specification in general. And so that's just kind of understanding what aggregates specifications, kind of just some of the basics. And so now when we talk about go into more of aggregate specifications in general, like I said before, it's either performance-based or end-result-based. And a lot of the specification in general, especially for aggregates, should be about understanding the availability, the application, the cost, durability, and serviceability of the actual project. I mean, you truly need to understand, how far does it take for your material. If your job site's 300 miles away from the nearest available quarry that meet, certain specifications, that may not be a very good, depending on where you're at. So you kind of have to, sadly, tailor yourself around certain specifications. And so in general, I kind of wrote down about 8 or 9 specifications that you will see in almost every application, whether they're more of rules of thumbs of this is just how it's always been done, or whether they're actually in the specified document. It's just very normal. So you almost always have a gradation specification. I mean, you just always have one. I mean, it's very common. People may say, I don't really care. I just want an ASTM, 57 stone, but it's still, they don't want a single sieve size. If you actually go and talk to them, hopefully they understand that though. But and then typically you have some type of maximum size where you don't want to get too big into a certain range. And especially for concrete, you want it to be freestyle resistant. You also, for riprap and drainage conditions, you may not, you want it to be freestyle resistance. You don't want the soundness, so the volume change, you don't want too much of a volume change. The angularity, shape, those, we talked about last time, where people typically like, depending on your application, sometimes in concrete people would prefer more river rock, where it has, more smoother, but typically, people want a very cubical shape aggregate, and then obviously you don't want a lot of chemical impurities like clay, or if it's ASR or ACR acceptable for concrete applications. And then your abrasion resistance, and typically you want to know your specific gravity and absorption. So those are always big things. And so this is actually a table that I really like in a lot of ways, but some of the information that's here, I don't necessarily agree with the people that put the table together in some ways. So I actually marked out some of the values and put in either better words, or I think they may have did some typos for some of these. And so I actually put my own stuff in, and I also added, you may not be able to see this very well, but I also added a column for riprap and subsurface drainage. And so just in general, this is the whole entire chart as you go through here of different properties. And so this is very, V means very important, M means moderately important, and then U means either unimportant or the importance is unknown. And a lot of applications with aggregates, it's actually unknown. And there's a lot of research that still needs to be done in understanding aggregates in general. But I would, for the most part, a lot of these I actually went through and looked at. I don't think this is necessarily an acceptable answer for me. I think it's more of U is unimportant. So I actually went through and re-looked and to make sure that these were acceptable values for me. And so again, I'm not going to go through and talk about all these specifications in detail for each of these applications, but I think this is a good summary chart table that actually explains kind of, you know, the importance of what we talked about in part 1 of these lecture series. So now we're going to go and talk a little bit about exploration. So exploration is when geologists go and actually try to locate aggregate deposits to supply a given market at a competitive price. So they'll actually go around and try to find a rock quarry or a sand source, and this is extremely important because the aggregate source, it must meet many physical, mechanical, chemical, and durability applications, and at the same time the geologist has to go through and do a cost analysis on all this. So he has to look at the processing, the handling, the sales, the regulatory expenses, and then the overall profit after he goes and looks at a source. And it's real important to understand very few sources are actually pure homogeneous, so they're not all a constant material property. They're, I mean, even with one source, I've tested the specific gravity, and they will actually differ slightly. The absorption will differ slightly, and it's not because necessarily of my results of me testing. It's more of they're just not all the same, and there's just a lot there, and you can also tell that color differences in your aggregate too, from 1 month to another month. And so it's very important to look at gradation, especially because that's almost every aggregate specification has gradation in it. And so obviously for sand, you don't want too fine of a sand, because a lot of the applications, they're just not good. People can't use them. And then a lot of times you also want to find a coarse aggregate source that can actually have a maximum size of at least 3/4 of an inch is very standard. And it's real important to realize you really have to be aware of outcrops. So those are actually where your a material source varies largely, where there might be just a single very small region in a whole acre that you found some limestone, and you really have to go around and look the whole entire area and really evaluate to make sure where that vein of limestone, where it really is at. So that's extremely important to do. And so it's real important to understand whenever you take into all the aggregate properties that we have already talked about and the chemical makeups, to understand kind of the variation in aggregate quality. Because if you have a lot of variation in your aggregate properties, it can be very, very, very difficult for an aggregate producer to meet a specification for a job application. So just in general, sand and gravel, the gradation varies widely. I mean, it even varies widely in between when did it rain last. And so you kind of have to understand on that river source, or if it's dry, that location where how your gradation actually is, and if there's too many clays and stuff, bad chemical impurities that make your source undesirable. And so typically with crushed stone, you have your 3 different igneous, metamorphic, and sedimentary geology names. And so with igneous, they typically tend to be the density and porosity tends to be very vary largely. And so, which would make sense that these 2 terms, porosity and density, as if you have a lot of porosity, your density, is going to, obviously change too. You don't have as much material. So, and they're also very highly chemically reactive for like ASR and ACR, and so it's real important to kind of understand what you have. And the metamorphic, they actually tend to be a lot more flat, so you may start worrying about your shape spec, and then they also tend to have a lower shear strength. So sedimentary, they may be a little more rich in clay, which clay retains a lot of water, which will cause your material to expand a lot more. And then the shell can also be flat. There's a lot of shell, may be flat, disintegrate upon wetting, and sulfate soundness, freeze-thaw may be a lot of issues. And so it's real important to kind of understand where what your chemical makeup is. So whenever you're starting to extract, a rock formation, this is just a basic definition: the removal of a substance. So whenever aggregate extracting is a well thought out process, you just don't go out and start digging. You really have to go and design and plan and develop and understand your operating. And after you get done with extracting all this aggregate, you have to go back and do a lot of reclaiming, and that's extremely important. Some people, after they get done with a rock quarry, just this big hole in the ground, and so they may make a pond out of it. And some of them can be very beautiful. If you get bored sometime, you can Google some of that stuff, and you'll actually see some pretty decent ponds with parks and stuff around them. And so when we're talking about extracting sand and gravel, typically it's a loose state, so you don't really have any need for blasting or drilling. And so usually you just go out and get a front end loader, power shovels, haul trucks, and bulldozers, and there's a lot of other things that go along into extracting it. And then so there's really two types of sources in general. You have dry or dewatered sources, which is where your material is actually not submerged in water, and then you have wet deposit sources where obviously it is submerged in water. And so typically when you want to remove it, extract it, you will actually dredge. You remove it with dredging it or dragline or float cranes for sand and gravel. And so whenever you talk about dredging in general, that is using like a bucket excavator or a large suction pump to remove your sand. And I've seen a lot of bucket excavators. I know there's one in Ponca City, Oklahoma, that I saw. And drag lines, I believe I've seen a few on the Arkansas River. And so this is actually a land-based crane that casts buckets just into the water. And then a floating crane is a grab type of bucket that's suspended on a cable from a boom to obtain the material. So if you want to get more of a visual representation of kind of these three ways to remove stuff, you can Google it. There's some very cool pictures of people excavating. So crushing or crushed limestone or crushed stone in general, when you extract it, typically this is produced from solid rock formations, and extraction, and it's a pretty big process of you have to drill and blast and crush, and you load out all the material. You combine it into gradation and load it out. And there's typically a lot of this. It all takes place at a quarry, and there's a lot of steps that are involved. And so you actually have surface mining and underground mining. And we're not going to really talk about underground mining in here. I actually have some material over it. A very cool diagram I found over underground mining, but a lot of stuff that we're actually going to talk about is surface mining. In Oklahoma, that's very typical, very typically found, and so that's what I'm really going to talk about. And so whenever you surface mining, you want to develop a quarry, and then you're going to go and so you don't remove the topsoil and the weathered rocks. So obviously you don't want a bad rock formation. So you want to and then you're going to construct a haul road to actually move your material around out of the quarry to the crusher. And so then you'll have a drilling and blasting, which various drills and explosives are used to break apart rock formations into manageable sizes. And a lot of this types and sizes of drills and explosives depends on many different things. Anything from your chemical makeup that actually goes along and your rock formations. It could do something with the the restrictions, either local or state, or the geographical restrictions. There's a lot of stuff there, and so and we'll kind of talk about each of these. And then you also have loading and hauling. So front end loader or a power shovel loads aggregate into an off highway truck to take it up the haul road to the quarry or to the crusher. And so it's real important whenever you're talking about loading and hauling to actually talk about optimum cycle time and to actually calculate how long it takes to load it, haul it, and actually remove everything. And so there's a lot of calculations. This is very important to kind of calculate as a quality and control engineer, for managing a plant and stuff. So in general, when you're going to design a plant, a very experienced plant engineer typically will need to do this. There's a lot of, you have to evaluate and formulate a valid design process. And so this is, a lot of this equipment that's actually being used is very rugged, massive, and expensive. I think it always thinks it's cool, but the little kid side comes out whenever I kind of look at, and watch some of these vehicles as they work in a quarry. So it's, there's a lot of expense that goes on there, a lot of man hours, and so you really want to design a very efficient quarry, because so many parameters may affect your design in general. And so the mineralogy and the material properties, the effects of drilling and blasting on a gradation, the potential waste products that go along with this. You're obviously going to look at your capital cost, types of installation for crushers, your operating cost, obviously the maintenance, just your normal plant operations, the method of stockpiling and storing is a big deal, and then also where you're actually shipping it. Are you shipping it on a truck? Are you shipping it on a rail, barge? There's many different ways to do it, and it's all important whenever you start setting up your quarry to understand where everything's at. And it's also important to understand how much available space do you have to kind of spread out, and you also have to look at your future growth too. And then safety is always a huge concern. So how does, in general, I'm just kind of going to look at a rock quarry or a rock plant in general at the crushing process. That's kind of what we're going to look at here. And so I'm not going to go into all these steps individually. Some of them are in my class notes. So you can go back and look at it. But this is just a flow chart of a typical crushed rock plant. So it's not, everyone's different. They all, like I said before, material sources. I mean, there's so many variables, and it also depends on what you're trying to produce. Will actually give you what how you're going to set up your quarry. And so after you go and blast, get your rock, and you transport it, up the haul road by the crusher. You're actually dump truck's going to go in a grizzly, which is actually a big screen where it actually separates gigantic boulders. So the big boulders will go here, and they'll go into scrapping. But anything that passes through a certain size will actually go into go through the grizzly and go through a jaw crusher, so a primary crusher, and then it'll go up this conveyor belt. And then sometimes you may have magnetic material, so you may have metals and stuff in your material, so you want a separator. And then you'll go into a pile, and then you'll have a pile that'll take it from the conveyor belt. Some of these, may be big, some of them not. They may just go straight to a secondary crusher. There's a lot of different steps. This is just typical, just a typical flow chart. And so, you may go to a secondary crusher if you didn't like the product that you received. And then you'll do a secondary crushing, which a lot of times is with a cone to change the shape so that the shape's nice and cubic. And then you may go and they actually start sieving the rock throughout all these, and then throughout all these screens. And so sometimes if it's too big, it'll actually go back through this loop and it'll get crushed again. And so it may get sieved. You might have a sieving process here, and then it'll actually go down, and you may have some more sieving here and here. And so what happens eventually, you will have where they actually go into bins, so they're actually get sorted into sizes. And sometimes some sizes aren't typically they don't want, so they may go into another crusher. And there's many different things that happen, and you can actually combine your gradation and your products here too. So a similar thing's done with sand and gravel. If they crush it, if they or sieve it, a lot of times they don't. A lot of times it's just they pulled out of the water. They may do some very light sieving. They may not. They may just take it. And so it just depends. So in general, this is kind of like the grizzly with the crusher. You have your field hopper. So obviously too big of sizes, they'll get rejected, and it goes through a conveyor belt. And then it goes on to goes over here, and it'll go to the surge pile, and then it will actually take it and screen it. And so there are many different how to say this. Sometimes you may have gravel and sand in your application. So over here, this over here is gravel, and this over here is sand. So what you can do is you can actually draw a line to kind of realize, there's this separation, or I guess you could draw it here, the separation. But so this is kind of with your gravel operation, where it's where it's very similar crushing process, and then with your sand, it's a little different, but typically, if they're going to sieve it, they really, coarse sand, a medium sand, and a fine sand. And, you can, our handbook, and there's a few other sources that you can look at to understand more about this. But I'm not going to really talk about it a lot because typically people don't have a setup like this a lot. This would be really helpful if it's a sand and gravel plant that's together and you want to separate your gravel and your sand. This is kind of what this setup's all about. So, but I'm not going to talk much more about that. So, we'll talk about the fracture mechanism of stone in general. I think it's whether you're talking about blasting or you're talking about crushing, it's very similar stone mechanism where you really need to look at your force, the distribution of your force, and then the aggregate characteristics. So how does your force and your distribution of your force, how does it affect your aggregate characteristics, your properties? How does it break up? So all three of these kind of go together. And so what I'm actually trying to say here is I really like this this analogy. They use it in the Aggregate Handbook when they're talking about a small hammer and chisel. And so if you've ever done any type of hammer and chisel work when you're trying to either write on stone or anything like that, you can get very precise, very detailed if whether you're writing on it or whatever, and you can really go and create well-shaped sizes and actually can really control your stone size by using more of a hammer and chisel as opposed to a sledgehammer, which you're just like boom, and then it reduces, it breaks it up, which is, that may be your goal, but you have, your shapes are horrible. If you ever broke up concrete before, your shapes are horrible, and then you have a lot of fines in there that you have to take up, and so that's kind of what we're trying to go here, where we have the three mechanisms of breaking stone. So you have abrasion, cleavage, and shattering, and so it's all about your energy. So I really liked what they had in the Aggregate Handbook. So I kind of added a few things though, and kind of made it more into a tabular format where you can actually see your fracture, and then with different forces, how does your rock actually fracture if it's the same rock. So whenever it's very low energy, it may fracture something like this, and then what your products actually is it'll be these, be one piece of big rock and a little bitty pieces of fine, and that's your abrasion. And so it gives you a description here too of it. And so you can see the same thing whenever you talk about cleavage. It's actually a medium type force of energy. It'll break up into more manageable sizes. And then shattering, where you just put a lot of energy into it and it just breaks apart like crazy. And so what I'm trying to get at, the most important, like I've said before, at a quarry, one of the most important things is, it's all about gradation, is a lot of it. Shape and gradation. And so if you look here, you have, they're actually plotted, so you can think of this almost as a sieve, if you sieve it. So this is your particle size. So you have large particles here, small particles here, and then the amount that's actually in there. So for abrasion, you have a bunch of large sizes, and you have a bunch of fine sizes. You don't have anything in the middle here. And then if you do something like cleavage, you will have a good, you can control your size particles a lot more, and if you need to break them apart, you can again, but you may break it apart, with a different crusher, and it may be over here, this time if you wanted a well distribution. And shattering it, you don't necessarily control your particles, but you do a real good job of breaking everything up. And so typically, obviously rock quarries, they don't really want a bunch of fines. I mean, people call them manufactured sands, and like we talked about in part 1 of the series, and this is, it's like trash that they're trying to give away almost. And they can use it in some applications, don't get me wrong, and it's very useful when you're fine grading stuff. But they just have mounds and mounds and mounds of it, and they need more. And so they don't necessarily, they don't sell as much as as other things. So they don't really want it. So now I want to talk a little bit about blasting. And so blasting in general, obviously, it's it's cool. There's a lot of cool pictures. We don't really have time to really look at all the pictures or anything, but I mean, obviously, it's very dangerous, and there's a lot of different safety guidelines that go into it that you have to look at. And so, kind of like what you're trying to do is you're trying to you take a rock formation and you're trying to blow it up so that you can make it into more easier to use particles, so you can crush them and create a gradation. And so it's very important to understand that too much force will produce too small of sizes. Too little concentration of force will produce too large of particle sizes. And so just kind of like what we talked about before with abrasion, shattering, cleavage, I mean, it's the same thing. And so here, I actually found this was really helpful about talking about blasting. And so you can actually go, there's just 6 steps here. So you go and you can actually survey your rock face to figure out where to put your dynamite or explosive, excuse me, at, and then you can go and drill your hole, check the hole, and then charge it with explosive, and then you can actually go and detonate it, and that your whole entire rock face will fall over, and then it's ready to be loaded onto the truck and to crushed. And so that's just kind of your basic steps into that. And so let's talk now, after you get there, the crushing process. So again, you're trying to crush it into desired gradation and a desired shape. I mean, that's kind of what this whole entire process, what it's all about crushing and screening. You're trying to get it into a certain gradation. That's the whole goal. And so it seems like there's a lot of threes. There's 3 crushing factors. There's 3 stages of crushing. There's 3 different ways rock fracture. But so I don't know if there's just nature or what, but there's just a lot of threes. And so there's 3 crushing factors that really go into your gradation. And so you have to understand the resistance of the material in general. So the material properties, I mean, that makes sense if it's really hard or if it's really soft, how easy is it to crush. And then also your reduction ratio. So how much are you trying to reduce the shape at once, or reduce the size? Obviously if you're trying to go from a big boulder to real small 1/2-inch rock, I mean, the ratio is really high, so it's going to take a lot more energy for it to crush and everything. And then also how much you're actually putting into your crusher at once. If you put too little or too much, they all actually affect how well the shape is and how well how much it'll actually crush into a certain gradation. And so typically you have 3 different types of crushers. You have a primary crusher. So this kind of reduces the large boulders into manageable sizes. Typically, this is a jaw or gravitory crusher. You have a secondary crusher, which is a lot of times a cone or impact crusher. And then you may use this if your cone crusher is just it's just not doing well enough for your shape or the gradation. You may have a ternary crusher, and but this isn't always common. It just depends on depends on all those factors we've already talked about. Kind of what goes into crushing in general. And so usually kind of like what we talked about with the 3 crushing equipment, the impact crusher, it exerts high blows causing high degree of shattering. So it's more of a sledgehammer, just bam. And then your jaw crushers or gravitory crushers, they exert low amounts of energy, causing more abrasion and cleavage. And then you have a cone crusher, which exerts moderate amounts of energy and creates cleavage and shattering. So it gives you more of that shape. It does more of a chiseling type thing. And so it's very common in a lot of quarries. And so it's real important whenever I was doing a lot of research in crushing equipment. I mean, the salesmen, they have some really cool stuff they like to show you. And so and again, they're selling products, but they can use a chart to kind of predict predicting the capacity and gradation of the equipment. And and obviously they can't take into the ability of your aggregate type, but they do a fairly good job. Some of those charts are very cool, very accurate to look at. And so you just kind of need to be aware if you ever have to deal with manufacturers that, yes, their charts are cool, but they sometimes can be a little more misleading. And another very important fact that we just talked about with crushing is your optimal feed. Whether it's sieving or crushing, you can only put so much in your crusher or when you're sieving or anything. And why is this important? It's kind of it's important to understand that there's this interparticle energy transfer to kind of achieve the effective performance. So there's some pretty cool stuff in the Aggregate Handbook that actually talks a little bit about how it all kind of works together. And if I was teaching this class, and I had like 16 weeks, we'd actually go through and actually show a lot of kind of the different types of crushers and kind of truly understand a lot of this. And I wished I could, but you only have a few lecture series. So now on to screening. And so this whole entire screening process is you're trying to, after the crusher gets done, you're trying to separate it into, various particle sizes. And this is very important because, the screen capacity, the efficiency, the screen depth, and each they all impact how it's all the production rate. I mean, it's very important to understand kind of how much. So if this is over here, if this is like if this is a sieve right here, and you have a bunch of rock on top, this height right here, obviously this is very important. If you have too much rock, you're never going to, too much rock height, you're never going to be able to sieve it all. Some of this will never even touch a sieve, touch your screenings or anything like that. And so they actually have a lot of formulas to make sure that you're getting the optimal amount of screening in your quarry. So there's a lot of formulas in the Aggregate Handbook about this. And so let's see now. And so another important factor to understand when you're screening anything is the moisture will actually affect your screening. Obviously, if your rock, your sand, whatever you're using is really wet, you're going to have problems. It's going to stick to the metal a lot more, and so you don't have a lot of problems. But I thought was really cool was this. I think this is in the Aggregate handbook, and it talks about your feed. And so as this is right here is your screen right here. Talks about kind of your small particles get sieved first, and as you go more and more of your larger particles get at the very end. And so your screen length needs to be a certain size, or you're just never going to if this is out of 100% or whatever, so some over here, this right over here, there comes a point where you're not really getting enough, so you may have to go back and recrush it or whatever, because you're just not getting optimal performance. And so also with crushing, there's other products that come about. So obviously stuff that gets rejected from your grizzly screen, they use as riprap. So typically this is 6 to 36 inches, and sometimes you may have to go back and minimize some of these large stones. You may have to break them up before you can even use them. And so this is riprap is really important for erosion control. And so there's some stuff you can actually read about in the class notes actually about riprap. I do a decent job on explaining some of the importance about it. And then like I talked about in the previous lecture about manufactured sands, it's a byproduct of the crushing industry. So after everything's sieved into different bins, there's still always this dust that's left over that no one typically, they can't really sell it. No one necessarily, there's not a big need for it. For fine grading, like I said previously, people will use it, but they won't use it in a lot of other applications. So right now is a big deal, actually trying to find uses for it in different applications. And so now, after it goes through the bins, and then they get handled into a gradation, it's real important to move the material in an efficient and timely manner. And this can be done, like you've seen with conveyor belts, with chutes, hoppers, a lot of different things. And typically your feeders and your gates actually go and monitor your flow throughout the process. And this whole entire process, after the material is screened and crushed and screened, typically when it's separated into bins, it's fractionating is actually what that actual process is. And so it's real important to meet, for a quarry, to meet a gradation requirements. Whether you're talking about asphalt or concrete, just in contractors, they need different, they require different gradations for their application. And so it's extremely important to be able to blend different aggregate sizes together, on either, to make a stockpile or on your truck out bins. And so it's extremely important. And so one thing I didn't mention, that there's a lot of, sometimes you need to wash your aggregates in general, and I'm not going to talk a lot about it because especially for crushed stone, they will actually wash it, but I'm not going to talk a lot about that today. But anyways, and that'll help with decreasing your variation. You don't want real dust particles on your rock. But to help you with your gradation variance, you actually, you need to maintain your screens. I've found that a lot where people just quarries will just keep using the screens, for weeks or months, where there's, that they clearly have holes and stuff in them, so you're not even getting the correct, gradation, aren't getting divided up correctly, but they make so much that they don't necessarily, you can't necessarily notice when they combined everything together, because it's a pretty exact process right now. And also the setting on your crusher, you can actually change the ratio by, if it's like a jaw crusher, you can change how much your capacity is, and you can also change your production rate, how much you have, and then the gradation, in and out of the crusher from your reduction ratio. That'll also affect your gradation variation. So loadout is a term describing the transportation process of the finished product to the customer. So typically the product's weighed out during the loading process and sold in tons. So the finished product is discharged into a dump truck, a rail car, a barge. I mean, there's many different ways to transport it. And so when you're transporting, it's really important to understand segregation. I mean, that happens with a gradation. And so what that is it's actually a separation of particle sizes from the overall mass. So, this example down here kind of shows a lot where segregation happens. Is very prone to segregation whenever you have handling, transporting it, you have poor storage, or you have a large range of gradation. It'll actually segregate a lot more. So if you look at a stockpile in general, many people dislike stockpiles because, say this is your conveyor belt and it feeds onto the stockpile, you actually have different gradations. That's why you never actually take a sample at a certain location. You have to take samples at multiple locations to figure out how well your gradation is. And I have some stuff in my notes about how to take a sample from a conveyor belt, a stockpile, whatever it is. And so it's important to understand that whenever the rock falls, the coarser rock will fall this way. The not as coarser but still coarse, that medium coarse will actually fall this way. And then you have more, not as coarse particles, more fine particles, more in the middle, and so you get segregation. And so if you're counting on your gradation to have a certain performance, and you have a stockpile that goes like this, and you're taking scoops with a excavator, obviously your gradations that you were predicting is wrong. And so to minimize that, a lot of people, what they do is they will actually go and change it up by many different ways whenever they store their aggregate. So, and we'll talk a little bit about all this. So you store, just whether you're talking about aggregate or you're talking about asphalt or concrete, typically they store them in a drum. Your drum or a central batch plant, you have some type of storage. It's always there. And so there's many different methods that people use to store and transport the aggregates in these plants. And so the more that, like always, it's very basic. The more you move your aggregate, the more it's going to be prone to segregate. So the more that the gradation is going to change. And so conveyor belts, not everybody use these. They use front-end loaders, but it can drastically reduce your segregation in general. And so it's important to understand that you want to reduce your segregation and increase your production and use a conveyor belt, because that's kind of it's always good to store it kind of in a bin. And that's just kind of the most preferred methods out there, is to use bins and a conveyor belt when you're loading everything. So sadly, a lot of ready mix plants and asphalt plants, they may be temporary just for a little bit, and they'll use stockpiles to store it, and they'll load it up with a front end loader, and you have a lot of segregation issues, and they don't understand why their gradation didn't perform the way they thought it would. So so the bins that hold all these to hold all these gradations, you can actually go and get completely different gradations to meet a combined gradation. So like a number 57 stone, a 3/8, and a sand source. That's been very typical, especially in concrete pavements lately, and a lot of ready mix plants will actually use a single bend of sand and a single bend of coarse, and they'll combine them together and make concrete with it. However, like asphalt, they'll use 6. They may use 5, 6, 8 bends sometimes to meet a certain gradation, because their gradation specs are very, very, very precise depending on what you're looking at. And so you can there's kind of 3 different types of techniques whenever you're looking at bends. So you can either sieve, you can literally go back. A lot of times asphalt, what they'll actually do is they'll actually sieve everything by a sieve size. They'll just have all the bins out there, and they'll just sieve them all into, they may leave the sand, but they will sieve all your coarse and your intermediate into different bins, and then they'll just recombine it whenever they're about ready to mix. And so you also have a 2-bin system, kind of like I talked about, with you have just a rock bend and a sand bend. And then, which is very, very, very common with ready mix. And then you have multiple bends, so 3 or more. Like I said, like a 57, a 3/8, and a sand bend. For asphalt, you may use like a 57, a 3/8 chip, or I guess the 3/8 chip could also be called for ASTM. Could be called like a number 89. And you may have a more of a manufactured sand. And then you may have a little bit of sand, so you may have 4 different bins there. So that and that's very common also. So the whole purpose of this lecture was to kind of understand in general about whenever you're talking to if you're a contractor or an engineer, and you're trying to talk to a aggregate producer, what they go through, the whole process, to just the basics. Whenever they tell you stuff like, we can't produce that, or, oh, but we have to change our coring operation around, that's kind of some of the basics of what they're talking about. And and I know, especially with contractors, I know because my family's just a bunch of contractors. They're very like, I need this product, I need it now, and I don't care. And you don't get to really see the other side of that, because you don't necessarily want to go drive all the way to a quarry and see what they actually do there, and you're more focused on getting money, completing a job, getting money, and leaving. And so hopefully throughout these lectures you may have gleaned some slight understanding about aggregates in general. And I do appreciate your time. If you have any comments, anything like that, you can email me. You can look at Optimized Graded on the web. So just in case you didn't get this from optimizedgraded.com, this is, I know I have probably 5th grader handwriting. I'll go with that, but I know it's legible. So. But that's the website, and that's where all these lecture notes will be published and free for anybody. So without further ado, I will turn off the